Good morning. My name is Karanveer Hansa. The topic I'm going to teach you is matrices. What is the use of matrices? Whenever we have to represent a data in tabular form, we use matrices. Let's take an example. When we have to represent the population of a city or the salary of the employees or similar data, we use matrices. In statistics also, we use matrices. Let me give you an example. In this example, we can see in this matrix there is 3 rows and 3 columns. So this is a 3 by 3 matrix. Another example. This is a 2 by 3 matrices. 2 rows, 3 columns. So 2 by 3 matrices. This matrices have 2 rows and 2 columns, so it's a 2 by 2 matrices. Now I will show you the general form of matrices. See, this is the first element, this is the element in the first row and first column. This is the element in the first row and second column. This is the element in the second row and first column. This is the element in the second row and second column. It is represented by A22. Since it comes in the second row and second column, so it is represented by A22. First row, first column, A11. Before coming to the types of matrices, I want to teach you one more thing. Five is the element in first row and first column. So A11 is 5. A21 is 7 because 7 is the element in second row and first column. Similarly, A22 is 9 because 9 is the element in second row and second column. Now let's go on the types of matrices. So first comes our row matrices and column matrices. So first comes our row matrix and column matrix. A matrix in which we only have one row and no matter how many number of columns is a row matrix. For example, in this matrix we have one row and 3 columns. In this matrix, we have 1 row and 5 columns. So these both, since they carry 1 row, that's why they are called row matrix. These are the examples of column matrix, in which no matter how many number of rows are there, but there should be one column only. In this matrix, there are 3 rows and 1 column. That's why it's called a column matrix. A matrix in which number of rows is equal to number of columns is called a square matrix. Here there are 2 rows, 2 columns. Here there are 3 rows, 3 columns. That's why they are called square matrix. A matrix in which the diagonal elements. Now what are the diagonal elements? Diagonal elements are the elements whose row number and column number are same. In this matrix, 10, 18 and 3 are the diagonal elements because their row number and column number is same. For example, 18. For this element, the row number is 2 and the column number is also 2. For 3, the row number is 3, the column number is 3. For 10, the row number is 1, column number is 1. So, those elements for whom row number and column number are same, those are called diagonal elements. Here 1 and 4 are the diagonal elements because row number and column number for them is same. So when in a matrix all the non-diagonal elements are 0 but only diagonal elements have some number, those are called diagonal matrix. For example, here diagonal elements are 1, 8 and 11 whereas non-diagonal elements are 0 everywhere. So such are called diagonal elements. Here such is called diagonal matrix. This is a diagonal matrix because diagonal elements are 1 and 2 whereas non-diagonal elements are 0. So these are the example of diagonal matrix. Now as I told you about the diagonal matrix, we will talk about identity matrix. Identity matrix is a subset of diagonal matrix, but every identity matrix is a diagonal matrix, but every diagonal matrix is not an identity matrix. The only difference between identity matrix and diagonal matrix is that in identity matrix the diagonal elements are 1. Let me show you. This is a diagonal matrix, this is a identity matrix because here the diagonal elements are 1, here diagonal elements are not 1. This is a diagonal matrix because here diagonal elements are 4, 3 and 7. This is a identity matrix because here diagonal elements are 1. This is the difference between an identity matrix and a diagonal matrix. Now we will talk about symmetric matrix and skew symmetric matrix. Let's come on symmetric matrix first. In symmetric matrix, the first thing you have to remember is that the non-diagonal elements, they should be symmetric to each other. Means the second row and first column element and the second column and first row element should be same. The third row and first column element and the element at first row third column should be same. The element at third row second column and the element at second row third column should be same. If they are same and the diagonal elements are non-zero, no matter what they are, then it is called symmetric matrix. Let me give you an example. No matter what diagonal elements are, the non-diagonal elements should be symmetric. The second row first column element and the first row second column element should be same. Let them say 5. Third row and first column element and the first row third column element should be same, and third row second column, second row first column, second row third column, these two elements should be same. So it is called the symmetric matrix. Now let us come on the skew symmetric matrix. A skew symmetric matrix is different. Just give me a second. The first difference between a symmetric matrix and a skew symmetric matrix is that in symmetric matrix the diagonal elements should not be zero, but in skew symmetric matrix the diagonal elements must be zero. No matter what, but in skew symmetric matrix the diagonal elements should be zero, must be zero, but in symmetric matrix they should not be zero. Now let's come on the diagonal elements of a skew symmetric matrix. In the let's come on the non-diagonal elements of a skew symmetric matrix. In the non-diagonal elements of the skew symmetric matrix, they should add up to zero. For example, the element at the second row first column and the element at the first row second column, they should be add up to 0, plus 3, negative 3. The element at third row first column and the element at first row third column should be add up to 0, plus 7 minus 7 or minus 7 plus 7. The element at third row second column and second row third column should add up to 0. For example, minus 10 plus 10. So this is an example of skew symmetric matrix. See, in the skew symmetric matrix the diagonal elements are 0 and opposite elements, non-diagonal elements opposite to each other are adding up to 0. Plus 7 minus 7, minus 10 plus 10, plus 8 minus 8. This is an example of skew symmetric matrix. Now we will talk about upper triangular matrix and lower triangular matrix. So in this matrix, please notice the diagonal elements 1, 4 and 6. The elements below them, below the diagonal elements are 0, 0, 0. And the elements above diagonal elements are 2, 3, 5. So the elements above diagonal elements are non-zero, whereas the elements below diagonal elements are 0. 0, non-zero. So in a matrix when the elements below diagonal elements are 0, whereas the elements above diagonal elements are non-zero, those are called upper triangular matrix. Here, these are the diagonal elements and the elements below the diagonal elements are 0, above are non-zero. So it is also an example of upper triangular matrix. In this matrix, 1, 3 and 6 are diagonal elements. The elements above them are 0 and the elements below them are non-zero. So this is an example of lower triangular matrix. Now we will talk about singular matrix and non-singular matrix. to know about these matrices, you have to know about the concept of determinant. This is a matrix. Let's say this is matrix A. Now we will have to find out the determinant of matrix A. Determinant is shown by two parallel lines. So how to calculate the determinant of a matrix? This is a 2 by 2 matrix. So to find out the determinant of this matrix, what you have to do is 4 into 1 minus 3 into 2. Since the determinant comes to be non-zero, so it is a non-singular matrix. If the determinant would have been 0, it would have been a singular matrix. Let us take an example of a singular matrix. This was a non-singular matrix because its determinant comes out to be non-zero. In this matrix 1, 2, 3 and 6, the determinant is 1 into 6 minus 3 into 2, which is a 0. That's why it's a singular matrix. Now let's take an example of a 3 by 3 matrix. Okay, I will explain you this. Determinant of matrix A is A11 into A22 into A33 minus A23 into A32. A22 into A33 minus A32 into A23 plus A12 into into A23 into A31 minus A21 into A33 minus A21 into A33 plus A13 into A21 into A32 minus A22 into A31. So the thing is, we have to take this element, do cross multiplication of this, then we have to take this element, do cross multiplication of these, but taking these two first, or we can take the negative sign outside, put it with it, and then take cross multiplication like this. Then A13 into cross multiplication of these. So determinant of matrix A, 1 into 5 into 9 minus 8 into 6 plus 2 into 6 into 7 minus 4 into 9 plus 3 into 4 into 8 minus 5 into 7. It comes out to be 45 minus 48 . minus 36 is the answer. Since it is not 0, so that's why this is a non-singular matrix. Thank you.